In this problem, we have an application from physics. We have displacement function s of t, which is 1/2 times gt squared plus v0t plus s0, where g is our gravitational constant. It's our acceleration due to gravity. It's negative 32 feet per second squared. V0 is our initial velocity. That's either going to be positive if we're spiking or throwing an object upwards, or it's going to be negative if we are launching the object down towards the ground. And S0 is the initial height above the ground. So for us, our function is going to be S of t is equal to negative 1/2, times negative 32 t squared plus our initial velocity, which in this problem is a positive 48 times t, plus our initial displacement, which is positive 64 feet above the ground. Simplifying this out, we get S of t is equal to negative 16 t squared plus 48t plus 64. First thing we want to find here is the average velocity. So to find our average velocity, we're going to look at our slope of our secant line, or average rate of change, and it's going to be s of our final time, which is 3, minus s of 1 divided by 3 minus 1. S of 3, if you calculate it in this function, is equal to a positive 64 feet. S of 1, which is again is our displacement at 1 second, that calculates out to be 96 feet. And our time is going to be 2 seconds, because that's 3 minus 1, of course. So our average velocity is going to be 64 minus 96, which is negative 32 feet divided by 2 seconds. It's going to give us negative 16 feet per second, which is just a coincidence that it's negative 16 is the coefficient on our function. All right, next thing I want to do is find the velocity when it hits the ground. Well, the velocity function v of t in general is equal to the derivative of displacement. So using our power rule, that's going to be negative 32 times t to the first power plus 48. So that is our velocity. But now we need to find out when it hits the ground. So to do that, we're going to hit the ground when our displacement, s of t, is equal to 0. So we need to algebraically solve negative 16 t squared plus 48t plus 64 is equal to 0, which is a simple quadratic equation. We can factor out the negative 16 from this and get t squared minus 3t minus a 4 is equal to 0. And this example factors nicely as negative 16 t minus 4 t plus 1 is equal to 0. It gives us either t equals 4 seconds or t equals negative 1 seconds. And of course, negative 1 seconds doesn't make sense in this application. So we're looking at t equals 4 is when we hit the ground. So now we need to calculate our velocity at that time at 4 seconds. So that's going to be v of 4, which is going to be negative 32 times 4 plus 48. All right, so that's going to calculate out to be negative 80. And the units on velocity are going to be feet per second. The last question in this application is, how far up does the object go? So the last thing we have to figure out is going to be the maximum height that the object goes. So again, that's our maximum. Not sure why it's writing so wide, but oh well, we just have to kind of go with it sometimes. Maximum height of the object. And that's going to happen when our velocity, v of t, is equal to 0, because that's when the object goes up to its highest point, stops, and then it starts going back down again. And so that's going to be when the rate of change is 0, because it's going to be basically stopped moving at that one instance in time. So if we set our velocity equal to 0, which again was negative 32 plus 48, again equal to 0, it's going to give us t is equal to 1.5 seconds. So at 1.5 seconds, we reach the maximum height of the object, and it starts turning around and going back down again. And now we need to find that displacement. So that displacement is going to be s of 1.5, which is going to be negative 16 times our 1.5 squared plus our 48 times 1.5 plus our 64. And that works out to be exactly 100 feet. So at 1.5 seconds in time, our object reaches its maximum height of 100 feet.